All right, 7.4. We're going to take a look at 7.4 at moving a little bit beyond just decimals into percentage as well. And we're going to talk a little bit about interest in this section too. So the first one we're going to do though is the percent. So the word percent actually comes from Latin meaning per hundred, as in our cent, right? A penny, cent, which is worth 1/100th of a dollar. So when you see N and then that percent sign, and we read N percent, it means N 100ths, as in a fraction. That's what it really means. And there's different ways to convert between a number and a percent. So I'm going to show you two methods. One method is to take the number as a percent, right, or the number, and write it over as over the number 100. So you have 790 over 100. In other words, you're sort of multiplying this kind of like it's the number 1, and you're multiplying both the top and the bottom by 100. So you're writing it as a number over 100. That number then over 100 is the number on top that is the percent. It's kind of like taking a look back at here and saying N percent means that same N over 100. So if I can turn my number into something over 100, then the numerator is the value that is the percent. Okay? It feels a little bit awkward. Another way to do this is to do this with proportions, which we've talked about. And to do this with proportions, you set up your 7.9 over 1, kind of like I wrote it over 1 here. And you write this as N, what we're trying to find, over 100. And then we can multiply, cross multiply, right? So you get 79, the 0 on the end, so 790 equals N. So this is the 790% that we were looking for. Okay. So all of that sort of beckoning you to have this idea that to turn something into a percent, typically what you remember and have done is you multiply by 100, right? So whether it's a fraction or a decimal or whatever, you're turning it into a percent by multiplying by 100. So if we took the first one here, part A, I'm going to do it with proportions because that's what we're less familiar with, just to give you some perspective of that. Because if you encounter some textbook that does it that way, and you know what they're doing, that would be unfortunate, right? Then you're going to be taking it to some cooperating teacher you have otherwise in your building, and you're going to be like, I don't know what's going on. And they're going to look at you and say, why don't you know what's going on? Okay. So let's take a look at this. We can take this 42.6 and write it over 1. And what we're trying to find is we're trying to find what this is equal to when the number is written over 100 instead. Okay. And we can cross multiply to do that. You guys like cross multiplying anyway. So N equals what? 4,260. And then as a percent, that's the number per cent that we were looking for. That number per 100. Pretty good? Okay, this is a little different because this is 8/3. It's fraction to start with, not actually a decimal, right? We can actually treat it very much the same way, and in this problem, it becomes very nice to use proportions. Because instead of writing this as 8/3 over 1, I can just write it as 8/3. It's already in a fractional form. So I can write 8/3 on the left, and I can write the N over 100 on the right, and then I can cross multiply. Okay? So I have 3 times N is 3N. And what will that equal? 800. And then what do I need to do? Divide by 3. And if you take your calculator, because that's okay at this point right now, we're going to do it, that's fine. What do you get if you do 800 divided by 3? 266.6 repeating percent. And if you don't want to write the 0.6 repeating, what else could you write? Whoops, sorry. You could do that. Yeah, so you could write 266 and 2/3%, because 0.6 repeating is 2/3. I don't care whether you do it or not, but if you see that written in the back of the book or something, you should realize that that's the same answer. All right, now I want to be able to take a look at changing a percent into a number, okay? And all you have to do to change a percent into a number is to write that number over the number 100 and then simplify. So in this case, we've got 4 1/2. So I can actually write this as 4 5 if I want instead of writing it as a fraction, and I write this number over 100. Now we've worked with dividing by powers of 10 last time. We did it with scientific notation. Okay? We didn't talk about it in quite that same way, but that's what we were doing. We were moving the decimals left and right. We're doing that? And the number of decimals we moved left and right had to do with powers of 10. That's why we were able to do that. So if I'm dividing by the number 100, in essence, what does that do to my fractions? Or to my fractions, to my decimals? Yeah, so when I divide by 100, I'm moving my decimal left twice. So right now I've got 4.5. If I move it left once, I've got 0.45. So I need to move it to the left again, and what do I get? 0.045, and just for practice, can you say that properly?
45,000.
Good, I hear it sort of in unison. 45 thousandths. Okay? So 4 and 5 tenths becomes 45 thousandths. How about the number 125? What do I get when I take 125 and write it over 100? Right, 1.25. Let's say that one right. 1 and 25 hundredths. Good job. Okay, now let's take a look a little bit more at problems that involve applications or problems that involve percents. There are basically 3 types of problems that involve percents. And every time you deal with one of these problems that involve percents, if you can identify which case you're in, you'll know how to solve the problem. And that's the most common mistake, is it's just to think they're in some cases they're not. Okay? So we're going to look at the 3 different ways or cases or forms or whatever that applications can occur or can take on. So finding a percent of a number. So a problem like that might look like something written this way. What is 15% of 32? So they're asking you to find a percent of a given number. What is 15% of 32? I'm going to show you the methods for dealing with these in a minute. I'm just showing you which the methods we're going to deal with right now. Okay. The second one says finding what percent one number is of another number. So this question might ask something like this. What percent of 47 is 12? So this is the kind of thing that your reading devices do when you're working on reading the books. If anybody has a Kindle, or if you've got an iCloud reader on your iPhone or something like that, and you're reading one of these books electronically, it tells you what percent of the book you have read. And this is what it does. It's using how much you've read out of how much the book is, how many pages the book is. And it doesn't even need to have the same form. So if I'm reading the book in one place, it's going to say it has more pages, right, depending on my device and how, zoomed in I have it and things like that. But it's going to find the same percent if we're both reading to the same spot in the book. Okay. All right. The third one is finding a number when a percent of that number is known. So it might look something like this. 13 is is 45%. Of what number? So let's imagine you're doing that same electronic reading of some book and somebody else has a paper copy of it, and they say, what page are you on? I don't know what page I'm on, but I've read 15% of the book, I've read 13% of the book, I've read 45% of the book, because my thing says I have. And if you're trying to equate that back to what they're looking at their numbers of pages of the book, you could do that and say, oh, we'll do that on the same page, of 432 of the 600 something that you have in that book, or whatever. So you can do that too. All right, so we're going to take a look at some actual examples of language problems written out, like problems with context. One of our concerns as we're doing this is we're going to have to figure out what type of problem this is, back on the previous slide, okay? But the cool thing is about all these problems is that you can use proportions on all of them. Okay? So the proportions are sort of cropping up again, Jack and Jill, wrinkling another appearance, right? So we're taking a look at them from that perspective. All right, so this one says, what is the sale price of a softball if the regular price is $6.80 and there's a 25% discount? All right, so a first consideration that you have to take and think about here is that if the discount's 25%, that's good to know. But what's more important to know to me, and should be to you as well, is if the discount's 25%, great, but that's not what I'm paying. How much am I paying of the product? 75%. Okay? So it's not about how much you save. I know. You guys think that it is. It's really not. It's really about how much you pay for the product. Right? Because if I save 75%, but I still spent $50 more on the product than I could have got it somewhere else, I didn't get a good deal. And that matters. So I need to really be thinking about how much I'm paying for it, not how much I'm saving on it. All right, so every time we're dealing with one of these, we're going to set them up as something over 100. So one side or the other, I don't care which side it is going to be the percent side. So if you know that percent, you know that amount over 100, it's going to go on the right-hand side. And we do. We actually know that we're going to pay 75% of the price of the product. All right, and then on the other side is going to go the amounts of the two different products. One amount will go on top, and one amount is the amount we don't know, and it'll go on top or bottom. I mean, we don't know which things go. We have to make that decision. And that decision is made based on how much we've got going on. This one right here says the softball's regular price is $6.80. So is the $6.80 the 75% price or the 100% price? It's the 100, so the $6.80 actually goes on bottom, which means this is the piece I don't know. So I don't have to look at this and say, do I multiply or do I divide? All I have to do is set it up so that it goes in the right location or the proportion, which is an easier way to set it up than simply deciding how equations should look when we're working with them. Okay? So I can cross multiply, right? All right, so I have 100x equals what? What's 680 times 75? 510? Okay. And then what? Divide by 100, and we worked on the previous slide on this divide by 100 idea. So what does this 510 turn into? $5.10. So that answers the question, what is the sale price? Which type of problem is this? Looking back on the previous slide. It is. It's problem number 1. We were asking, what is 75% of 680? So this is an example of problem number 1. Okay, let's look at another one. Next one. Mort bought his home in 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of his house to the nearest percent? So, the easiest way to set it up is with a proportion, right? Because the proportion tells me where everything goes. I know there's a 100 here. That's awesome. You get to start there. Okay? So, in this problem, do I know the value that goes on top of the 100? No. No, I don't. Do I? No, because it's the percent that goes on top of the 100, right? So that's actually what I'm finding in this problem, and it talks about that too. It says, find the approximate percent of increase. That's what I'm looking for. I'm looking for a percent. On the right-hand side, left-hand side, move my hands around. On the left-hand side, I've got these two different values, and I need to figure out which one goes where. Okay, so what do you think? What do you do on top? 195. So it is going to be 195 on top and 159 on bottom. How come? How do we make that decision? So 195 is the new price.
159,000.
$159,000 was the original 100% of the price of the house. And we know the price has gone up. We don't know by what percent it's gone up. But that's how the problem can be set up to think about it. Right? So the 159 is the 100 original percent. Excellent. So we can cross multiply, right? So I have 159,000 x equals 195,000, and then I need two more zeros, so it actually ends up being 19,500,000. And then what would I do? Okay, so somebody's going to grab a calculator. Okay, so let's go with 2 decimals, because it's not exact, is it? Or was it? It kept going, didn't it? So let's go with 2 decimals. What'd you get? 0.64. Okay, percent. Now, I want you to pause for a minute and ask yourself, did you really answer the question as fast? Yes. No, not quite. It wants to know the percent of increase. So if the house was originally 100% and now it's 122 and 60.64%, what's the increase? 22.64%. So this is kind of like the Jack and Jill question of when you get X equals doesn't mean you're done. You need to make sure that's really what you're asked to find. And it wasn't quite. What type of problem is this? Somebody said it. Number 2. Number 2 is the only one that asks you for a percent. It doesn't give it to you, right? So this is an example of problem number 2. All right, we've got one more. It's aching to go skiing, so you get a problem about it. A ski area reports that 80% of its runs are open. If there are 60 runs open, how many runs are there at the ski area? So, set the problem up with something over 100. Good news is there's always a place to start when you're starting with proportions, right? Okay, so somebody tell me what to put where next. 80 goes on top of the 100 because it's the only other percent given, right? The only percent. All right, now what? 60 goes where? On top, because the 60 is related to the 80% that are open. Whereas what I'm looking for is how many really exists, right? All right, so have 80x equals what? 6,000. Divided by 80, what do I get? 75. And just like before, context problems have language answers. You can type in like 75 runs. We had dollars in the last one, or second 2 ago, and then we had the last one was the number of percent. All right, so what type of problem is this? It was the third one, and this one we were given that 60 was 80%, I'm sorry, yeah, 60 was 80% of what number? So this is problem number 3. All right. We are going to take just a few more minutes. We're going to talk about mental math before we stop for today. All right, mental math. Love mental math. It's good stuff because you don't have to have a calculator with you all the time to do some of these things. And believe it or not, you probably used some of these, and maybe not all of them, and this will help you sort of when you're out and about thinking about stuff too. Because there's always those cases where there's a sale for 25% off. You don't have a calculator to figure out what the new price is. If you're Kohl's, they tell you, because it's on top of the thing. Maybe it's Kohl's. But not all stores do that. They'll just put a thing that says 75% off the cheapest price listed, or 25% off the cheapest price listed. It would be good to know whether it's a good deal or not, because just because it's a percent off doesn't mean it's a good deal. All right, so 25% is a decimal, or is it it's a percent, and we want to know the fraction that's related to it. What fraction is 25% related to? 1/4, right? What fraction is related to 50%? It's 1/2. And 75%? 3/4. Good. What fraction is related to 33 and 1/3%? That's 1/3. About 66 and 2/3%. 2/3. 10%. 1/10. And then 1%. 1/100th. So I'm going to show you some ideas about how mental math is used, and we're going to talk about what you have to show me, because it sounds a little funny to say that I'm going to do some problems with mental math, but you've got to show your work. So you're going to have to show me some of what you're thinking, and I'm going to show you what I mean by that. All right, so this says solve the following problems using mental math. 15% of $42 sounds an awful lot like something you might be trying to calculate if you're calculating a tip at a restaurant. Okay? Now, I don't do a tip at a restaurant quite like this, and maybe you don't either, but some people do. And I'll tell you for sure and certain this is exactly what my grandparents do. They'll sit down, pen and paper, and figure out the exact amount that they want to do on the tip. You probably have grandparents something like that too, maybe great grandparents, I don't know. So we've got 15% of 42. What could you do to figure out what 15% of 42 is in your head? Okay, so Cicely wants to change this basically to figuring out what is 10% and what is 5%, right? So how can you figure out what 10% is? $4.20, and you do it by just moving the decimal, right? So we can move our decimal. So the 10% is $4.20 by moving the decimal. How can you figure out what 5% is then? Half the 10%, right? Sure. So what would this be on this one? 210, because this is half of the 10%. We'll say it that way. And then if we add those together, we will get what? 630. And then you're probably going to round up or down or something like that to make it a nice number, aren't you? 20% of 280. So how could you figure out what 20% of a number is? 10% twice. Either do 10% and add it to itself, or do 10% and multiply by 2, right? Okay, so what is 10% going to be? 28. So the 10% is 28. And again, you did that by moving a decimal. That's not decimal. Okay, and then what would you do? Sure, you can multiply by 2 if you'd like. So then we're going to double it. And what are we going to get? 56. That's right. Okay, how are we going to get 5% then?
Get 2%.
Okay, so you want to get 10% first. So what's 10% of 28? 280. Okay, so we move the decimal. And then you can get 5%. This is much like problem A or whatever here, right? And then you get 5% by halving that. So you get 140, right? So this is half of the 280. All right. There's at least 2 ways to get 25% of 84. Somebody give me one. You could do 2 10s and a 5. So you can do it very much like what we've been doing on these problems, and if you do that, that's fabulous. Okay? Alternate method. Divide by 4. That's where the fractions idea comes in that previous slide. It's actually pretty nice, right? Divide by 4. So we could take and find 25% directly. And again, if you do it the other way, it's fine. But you could find 28% directly by taking your 84 and dividing it by 4. And this one actually divides by 4 very friendly to give you what? 41. Okay, so 21. Oh, I'm sorry, 21. I'm not hearing right today. Okay, so we divide by 4. Okay, let's do one last slide and then we'll stop for today. Okay, example number 7 says, does 0.4 equal 0.4%? Okay, so no is your answer. Many of you learned from the last test that the word explain means what? Give me some details. How do you know? It means explain, right? So what? How do you know? What does this mean? Why does this not equal each other?
Well, to get a percentage. Or like.
Okay, so let's take one of the numbers and figure out what the answer should be. Would that work? Okay, so which way do you want to go? Do you want to turn the percent back into a number, or do you want to turn the number into a percent? Number into percent. So you want to take the 0.4. So what are we going to do with 0.4? Okay, so 0.4 is 0.4 times 100 as a percent, which is what? 40. So this is 40%, not 0.4%. That'll work. I'm okay with that. You could also take the 0.4% and turn it into a number instead, right? And compare them, and that would work equally as well. All right, so let's talk about example 8. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price? Okay, so let's talk about the increase first, Kayla, and then we'll come back to your issue about the decrease. Why can we have an increase of 150% in price? Can you give an example? What would that look like? That's not the decrease, though. But you can increase 150% in price.
Well, if anything, whatever goes up, so, I mean, like, he said gas, like gas was something and then it increased.
Okay, so can we use $3 for gas as an example? Okay, so $3 of gas today could increase 150% by tomorrow.
Oh.
Let's hope not. To what? What would it become if it was increased 150%? It'd become 450. Is that what you guys said? What did we say? Okay. What would 450 have been? Nicole, did you say 750? Or was it Cherry? Was it you? Cherry said it was 750. Okay, so where does 750 come from?
Well, 100% is 3. So really, it's 100% is 6. And then 50%
Right.
So, you know,
Good. Okay, so you increased it by 100% first. This is kind of like what we were doing on that last slide when we were doing the mental math. Increase of 100% means it doubles. And that's what it means. So it would go from $3 to $6. And then if it increased 50% more than that, it would be 50% of the $3, which would be another $1.50. So the $4.50 that we wrote down originally was actually just a 50% increase in price, wasn't it? Yeah. So we've got a $7.50 increase. So thinking about that, why is it possible to increase by 150%? And the issue is because you're adding additional amounts to the existing value. And in essence, I mean, this is what any retailer does. Anybody who sells you anything has to do that. If they don't, they're going to close up shop. I mean, that has to happen. If they don't make a profit, if they don't make money in their business, they will not be in business very long. So it may sound fabulous to go get free, something at Sonic or whatever, but if they give away too much free stuff, Sonic won't be there any longer. Okay? All right, so why can't we decrease, Kayla?
Because you can't have negative growth.
Right, so if we did the same thing with the gas,
Yeah, you would have like negative
They would be
or
paying
negative
us.
450.
they would be paying you to get your gas. Wouldn't that be awesome?
Yeah,
That'd be
well,
great. And then they really would go out of business, right? Yeah, so the issue here with the decrease is that if you decrease, if the decrease is more than 100%, that's the issue, right? If it's more than 100%, the price would become negative. I.e. paying you to take the stuff away.
They do that on extreme coupons.
They do. In essence, they'd be paying you to take away the product. And as a whole, a store can't do that, right? They might have situations where they do something like that with the couponing or whatever, but they can't do it on everything all the time, or again, they're not going to save business very well. All right.